Good morning, everyone, and welcome. My name is David, the Marketing and Communications Manager for Graduate Apprenticeships here at Heriot-Watt. Thank you very much for taking the time to join us today. I'm going to cover off some quick housekeeping before handing over to Alan Faulkner-Jones, who's the Programme Lead for Engineering, Design and Manufacture. The webinar is being recorded. All lines are automatically muted. However, you can use the Q&A function on the right-hand side of your screen to ask any questions. What we'll do is we'll cover off any questions that come up at the end of the presentation. So, without further ado, I'm going to hand you over to Alan for the presentation.
Thank you, David, and good morning, everyone. Next slide. So, yes, as David says, I'm Dr. Alan Faulkner-Jones, and I will be talking about the graduate apprenticeship in engineering, design and manufacture. So there's actually two programs called design and manufacture, and there's a third one called instrumentation, measurement and control, which has some similarities, but we'll just be concentrating on the top two this morning. So there's a mechanical variation and an electronic. And we'll cover off more details about those, but they are two distinct programs. So in terms of delivery of these, they are 1 day a week on campus, so a day release as we knew them from days of old, but we do suggest they take about 4 hours a week additional study to tie in the work-based elements to the university taught-based elements, just to tidy everything together. There are two core taught courses every year. I'll cover that in more detail, what that means. There are 3 semesters, unlike the traditional undergraduate degrees that finish after the second semester. These graduate apprenticeship programs at Heriot-Watt have 3 semesters, which cover about 42 weeks of the year. There's still the traditional breaks at Christmas and Easter, and the summer break is still there, but it's a lot shorter than the undergraduate break is normally. That's basically the August and a bit of July, a bit of September, that kind of thing. It is a 4-year program, which is different to some other routes to get your this level of qualification. The final degree is the same as an undergraduate 4-year program because it is an undergraduate, so you get a Bachelor of Engineering with honours. And in terms of assessment, because this is a very much of a work-based degree, then the work-based element takes up, on average, about 80% of the assessment. University learning is 20%. So the work-based learning the work-based element is of the practical elements of demonstrating the learning in the workplace. And the apprentices provide the university with evidence which we mark. All the content in there is agreed with the employer. Ideally, these are activities which the apprentice is undertaking as part of their normal job role. And then basically they're getting university credit for their job. On the other side, the university learning, the core courses, which take up the other 20%. These are more traditional courses taught in a lecture tutorial style. Assessed on campus, either an exam or more usually a class test and coursework. There are far fewer exams in graduate apprenticeship type programs than there are in traditional undergraduate degrees. So in terms of monitoring, because these apprentices are only on campus 1 day every week rather than every day as in most undergraduates, we need to make sure that there's a robust monitoring process in place. So in order to act as a focus, we have this process called the Individual Learning Agreement, the ILA, and we make sure that we have these meetings at least quarterly between the apprentice themselves, their personal tutor from the university, and the workplace mentor from the workplace, just to make sure that everyone knows what's going on, what's being learned, what experience is happening, what may have happened which wasn't to plan, either positively or negatively, demonstrate how what they've done in the workplace is meeting off the framework outcomes for the graduate apprenticeship degree itself. In order to do this, the apprentice is slowly building up evidence on the activities they've done, putting it into a portfolio, and in order to help them, every course in the program has a course specification which lists pretty much exactly what they need to do in order to meet the outcomes for that course, and there's some suggested activities in there which the apprentice and their work-based mentor can discuss to work out what works for them in their particular environment. As you might expect from this, every apprentice therefore will be submitting completely unique evidence. So this is very different to how we assess the traditional undergraduates, because every single piece of coursework we come in from apprentice will be completely different to another apprentice on the same program, because their work roles will be different. And the last thing on there is development plan and activity tracking. So it's an individual learning plan, which is an evolving document. So basically they start one at the beginning of the year, and then it gets monitored and updated and tracked throughout the year. And then they have to set specific goals for what they're going to do for each activity they're doing at work, which meets the framework outcomes. In terms of support, obviously it's a tripartite thing, with the apprentice being one of the sides. So the other two sides are the university and the workplace. So on the university support side, we support the apprentices with obviously the classes, lectures, tutorials, seminars, workshops, that kind of thing. And we tailor our support and resources to the apprentice. Obviously, because we're not giving the lectures throughout the week, we can only give supported sessions on the contact day. So we tailor the actual resources that we deliver to the students to help them in their specific examples. So if they have a specific application of some piece of theory that we're teaching them in the workplace, then we can tailor the resources that we're teaching them with, so that to help them in order to apply it to the workplace. Obviously, as I said, all of the pieces of work that they're submitting as evidence are completely individual, therefore the feedback is also completely individual. And we support them with their individual learning and areas for improvement, which is based on the GA framework. We can identify the gaps and things which they haven't necessarily been able to tick off in the workplace, and we can set simulated exercises either in the university or in the workplace for them to do, or just now, of course, it's simulated activities that they can do in isolation in some cases. On the work side, they obviously have their mentors, which are assigned, which aren't usually the line managers. It's an extra person that they can go to, and they provide obviously the management support out with the normal structure. In some cases, if the apprentice is a new start completely to the company, then they will help them support the transition from wherever they were before to the company. So in the case of new people who've just finished their students who've finished their hires or advanced hires, for example, they'll help them in the transition from schoolwork to work. But primarily they're there to help suggest the work-based activities that the apprentice can do over the year to meet the outcomes, and to provide feedback and concerns they might have with the whole process, and to discuss them, because obviously they'll be available much more than the university will, because they're at the workplace 4 out of the 5 days every week. So in terms of benefits to the industry, with a learning organisation, we've structured this framework to support the apprentices through from beginning to end, but there are a number of entry points. It's not as simple, straightforward. It is possible to enter at stage 2 or even stage 3 at some situations. It's a new skill set, fresh perspective for industry. We've got a lot of new people coming in. You can then use this as a vehicle to mould them to a specific role that you have in mind for them at the end of the program. It's an improved quality of service. Industry feeds back in straight away to the program and has the capability to change the program if they identify any gaps. The program has evolved over the last 3 years directly as a result of industry feedback. Retention of apprentices, obviously we hope this is the thing, but this is obviously up until this point, apprentices could only get as far as the modern apprenticeship really, and then they've often can't progress any further than this, so this is the route for them to continue their development and learning. And it helps obviously existing employees to enhance skills. This doesn't have to be existing apprentices or people fresh out of school. There is no upper age limit on the graduate apprenticeship scheme, so we do have people on the programme which are upwards of 50 years old. Onto the specifics for the engineering design and manufacture graduate apprenticeship and why we're doing it at Heriot-Watt. So we've been doing this kind of thing, or this is the kind of thing that we started doing as an institute. What became Heriot-Watt University was founded in 1821 as the world's first mechanics institute in Edinburgh, as the James Watt Mechanics Institute. We're in the current day, we're very highly ranked in terms of our engineering programs. We're #1 in Scotland for mechanical engineering, the Guardian 2020 University Guide, and #2 in Scotland, the Sunday Times Good University Guide. We're also #1 in Scotland for the National Student Survey 2019. Obviously the 2020 data is not available yet. In terms of accreditation, this program's been running since 2017, so we haven't had any graduates from it yet, but we do expect to have some this year. So in order to do that, we've approached the two main industry bodies for these kind of things. So the Institute of Engineering and Technology this year provisionally accredited the degree towards chartership and fully surpassing the requirements for incorporated engineer status. And we were under consideration from the Institute of Mechanical Engineering. They were actually at the university on their accreditation visit when they were recalled by the Institute, thanks to COVID-19. But we fully expect that to be provisionally and then accredited by the IMechE once we have some graduating students as well. So that will be again surpassing the requirements for incorporated engineering and towards the requirements for chartered engineered status. In order to go from that towards CEng to a full CEng, we do have other programs at the university at master's level which would provide that top up. So in terms of aims and outputs for the program itself, basically to make this particular graduate engineer, we're putting in all the same engineering principles and some new ones. They will be learning how to be multidisciplinary team workers, in some cases more than our traditional undergraduates. They have to understand the influences of engineering and the impacts of their work in engineering has on society and on engineering itself. They're going to learn how to be problem solvers. They're going to develop their personal qualities and professional competencies. We want them to be a well-rounded individual. And more importantly, in this particular instance, they will be tailored and contextualized to the needs of your specific company and the role that you desire them to occupy. Program structures. So don't worry too much, but if you are interested, we can go through this in more detail at a later date. But just to give you a flavour about how the program is actually structured and the kinds of topics that they'll be studying. There's your 3 semesters there with mandatory and optional courses. So as I said, there were 2 programs here, which is why it says mostly common. So everything at the top there is mandatory, so they'll be doing Maths 1 and Maths 2, Design and Manufacture, Analog Electrical Fundamentals, Mechanics Fundamentals, Electrical Laboratory Skills and Programming, and Engineering Practice, which is more of your soft skills and presentation and that kind of thing. And then the optional courses, that kicks in semester 2, and that's deciding which of the 2 programs they're going to go on. So if they're going down the mechanical engineering pathway, then they'll be doing thermofluids fundamentals, and if they're going down the electronics electrical engineer, then they'll be doing digital logic and systems. And then from second year onwards, the two programs split, but there are still quite a lot of common elements. So they're all still doing Maths 3 and Maths 4. And then operations management as well starts, which is you might note that's a different code. It's a C-coded course that is delivered by our School of Social Sciences and Edinburgh Business School. And then from then on it splits. So they just do the left, which is the mechanical stream first. They continue on the design and manufacture route, and they have a design project. And then all the other 3 course slots, they have to do 120 credits or 8 courses a year, is an optional. So they get to really be able to tailor to the requirements of the specific company. So you've got all your standard things. You've got strength of materials, machine dynamics, fluid mechanics, thermodynamics. You've got a new course there, which just started this year, which is materials engineering A, which is more specifically into the engineering of the materials themselves. And they also have the option to choose one of the electrical courses. And on the electronics side, you've got embedded systems and programming, circuit analysis, a design project, which is very similar to the mechanical one. And then they get just a choice between electromechanical systems or instrumentation and robotics. Third year continues on the same structure, but the maths is now gone. They've learned all the maths they need for all the 4 years. So in mechanical, they get more heavy design and manufacture. In electrical, they get more electronics and electrical. And we get more management and more optional courses. I'll stop describing them specifically in this case because they're just drilling down into the more specific topics and building on the advanced materials in those areas. So once they've chosen their options in second year, they can continue on becoming more tailored and more specific in their roles. Until we get to fourth year. In fourth year, half of the year will be taken up by their individual project. It's their dissertation project. There's 2 courses, which are 30 credits each. So it does take up a fair chunk of their time. In mechanical, engineering design and engineering manufacture carry on, and then they've got options to make up the last 30 credits. They can either do an employer-based activity, which is them getting credit for a specific job that they're doing in the workplace that meets some of the theory that we've taught them in the first 3 years, or they can pick an advanced subject, which is listed there. In electronic, they get to choose the 2 taught courses from a list of 4. So there's an option there between advanced analog electronics or linear control, and then advanced digital electronics or sustainable energy and power systems. And then they do the 60 credit dissertation again, and then they have the employer activity as well. And that's the presentation. So thank you all for listening. I'm happy to take any Q&A. David.
Thanks, Alan. Thanks for that really useful insight into our EDM programme. As it happens, I think you're off the hook in terms of questions this morning, unless MD would like to type in a quick question as we just kind of finish up. There's nothing coming through just now, Alan. So I mean, I suppose if nobody's got any more questions, we can wrap the session up. I hope you found that a really good insight into the programme, and I would just really thanks again for joining the session today. Just a couple of quick things before we finish up then. If you joined the session anonymously, I would really appreciate it if you dropped an email into our mailbox, and we'll send you a copy either of the slides or a link to the recording. So our mailbox is ga@hw.ac.uk. So yes, please do that. And also, we are very interested to hear any feedback you have on the session. This is our first one of these, so we'd like to make this as good an experience as possible for any future attendees. So any feedback that you can give us via email would be greatly appreciated. And I'd also just like to take the opportunity just to sort of recap on some further sessions we're having over the rest of today and also tomorrow. So this afternoon at 2 p.m. we're having a software development for business All these links are available via Eventbrite, or again, please drop us a note into the mailbox and we can send you a link directly to the sessions. So software development for business this afternoon, and tomorrow, Alan mentioned it briefly before, we have our engineering instrumentation measurement and control session, which is at 10 AM, and in the afternoon we have our data science session, which is at 2 PM. So if you'd like to attend any of those, please drop us a note and we shall send you the link. So if there's nothing else, no other questions have come through, I'm quite happy to close the session at that. And thanks again for your attendance today, and we hope you enjoyed it, and we hope to see you virtually on future sessions. Thank you very much.